Hello, everyone. Welcome to our webinar here for May. I'm Paul Deffenbaugh. I'm the editorial director at Metal Architecture Magazine. Today, AEP SPAN is going to deliver a webinar on metal roof systems, design and installation considerations. We're glad you all joined us. And thanks for sticking with us to our new time at 2:15 Eastern, which gets us out of the way of all the craziness that happens in the middle of the day. And I hope things will run more smoothly now. In just a moment, I'm going to turn things over to Jeff Medeiros, who's our speaker today. Jeff's got a lot of material to go through, and we're going to hold questions to the end. Even though, rather than wait to ask, I recommend you submit them on the screen panel. I'm going to monitor the questions after and raise them with Jeff afterwards. There will be handouts available. You'll get an email with a link to download those handouts. The email will come tomorrow with more information. For those of you who are looking for certificates and AIA credit, that will be handled automatically. In the past, we've done it differently. This time, it's all going to be handled automatically. Just allow 7 days for everything to process. And as I said, you're going to get an email tomorrow with more information about view the webinar again, to ask technical questions, and to download the handouts. But now, I'd like to introduce our speaker. Jeff Medeiros is the architectural representative for AEP SPAN and is a licensed contractor who has been supporting architects in California for more than 10 years. Jeff can spec write, assist in detail drawing, and aid in product selection or any aspect of the design build process, from initial design to complete bid-ready documents. He's fluent in building code, bid laws, and contract code. Jeff provides architects with a full range of service from conception through bid. He holds various degrees, including law and society from UC Santa Barbara, Japanese from Waseda University in Tokyo, and he attended McGeorge School of Law in Sacramento. He's fluent in all types of roofing systems, built up and torch applied, hot and cold process, restoration coatings such as silicones, urethanes, and acrylics, single ply roofing, and all forms of metal applications, including roof, wall, coping, and soffit, as well as flashing and trim. Jeff made the move to AEP SPAN 2 years ago after spending years with a competitor and plans to stay on through retirement. Jeff, thank you very much for presenting today. Why don't you take things over?
Hey, good morning / good afternoon to everyone. Hopefully everyone can hear me. I do want to preface this call by letting you know that as most of you most likely may be, I am also in lockdown, working from home. So if you hear children running and or dogs barking and other disturbances, I just wanted to preface this and issue an apology off the get-go. We're going to start off metal roofing systems, design and installation considerations. This is more of a roofing 101 metal course. We're going to go through quite a few things. Course number listed there, and learning units listed there as well. I'm going to skip past this slide pretty quickly. So at the end of this, I hope you will be able to list the advantages and the disadvantages of architectural roofing versus industrial roofing, as well as the features of exposed fastener systems versus standing seam systems. The specification considerations related to a metal roof installation, being able to discuss the energy efficient features of metal roofing and the environmental impact of metal roofs versus alternative roofing systems such as single ply, asphaltics, and so on. And we're going to go over the design and installation issues that help facilitate a successful metal roof installation. So this course begins with a discussion of the pros and cons of architectural roofing versus industrial roofing, followed by an overview of exposed fastener roofing systems and standing seam roof assemblies. Specification considerations that are critical to a successful installation will also be reviewed, such as proper substrate, underlayment, material selection, metal gauge, coating, sealant, and so on. So let's start with an evaluation of the types of metal roofing applications. So, architectural roofing and industrial roofing. What are they? The two major applications for metal roofing are architectural and industrial. An architectural roof system is specified for performance, life cycle costs, as well as aesthetics, in that the roof is often part of the overall architectural design. Non-structural metal roofing usually requires a solid substrate beneath it, such as plywood or a metal roof deck or rigid insulation over a solid substrate. A low-slope industrial roof system, on the other hand, is selected more for its function, its performance, when cost is the major factor for a project, and feasibility. Structural metal roofing attaches directly to the secondary structural members and may not require any sort of solid support beneath it. Now, I know you probably have a question here. Do architectural systems are also structural? Yes, I'll go over that later. There are many architectural systems that do not require a solid substrate beneath it. The advantages and disadvantages of both architectural and industrial applications are presented on the following slide. So if we were in person, I'd go over this and point to certain things, but given that we're on a webinar, I'm going to let you take a gander at it real quick. I'll touch on a couple things and then we'll move on. So the main thing that I want to point out here is concealed fastener versus internally cleated systems. And since this is available, we're going to skip past that and move on. So exposed fastener roofing systems. This is considered a standard in the metal building industry for well over 50 years. Exposed fastener roof systems are also known as through-fastened systems. They provide an economical performance value option. They're durable, they're lightweight, you can get them in different finishes and textures. They can be installed on a roof, vertically, horizontally, in a wall application, and so on. Many exposed fastener configurations are fabricated in varying gauges, from very light gauge like 28, 26 through standard roofing gauges 24, 22, and 20. And they can provide both high negative and positive load carrying capabilities. Note that some types of exposed fastener panels have been tested to provide diaphragm support. So an exposed fastener panel, along with the favorable attributes, it has certain drawbacks. So as you can see, these panels are nestable. And what nestable means is you can stack them on top of each other and ship a bunch in a crate. They do rely on a visible fastening device for connection to the desired substrate, and they do require field-applied sealant to further improve the weather tightness of the assembly. These panels are also pinned at every attachment point, so they don't allow for much thermal movement, which I'll dive into later. Could be an issue. Exposed fastener roofing systems over time, the expansion and contraction of the panels create an elongated hole at the screw location and jeopardize the weather tightness attachment of the panel. They can also have fasteners that back out. So I'm sure you've all seen a fence where nails are backing out and you go, hey, I need to put that nail back in as you take your trash out. That can happen in metal panels as well. And as they expand and contract and that hole gets wider and wider, you may have to do some fastener replacement. So typically exposed fastener panels should only be used on shorter panel runs, and I don't recommend them for slopes less than 1 in 12. In these cases, a standing seam roof is far preferred. So standing seam. Let's review the features of this. Standing seam have a tall seam on either side where the panels interconnect that resists leaks. Factory applied sealant is available. They're easy to install. They're very weather tight. Some have a floating clip with concealed fasteners. Some have a seamed in clip, which I'll dive into down the presentation. And they are also available with bearing plates for rigid insulation, which again, I'll dive into later in the presentation. This does increase the clip footprint and spreads the load of the clip, so you don't have to use like a 1/2-inch chip. So standing seam configurations, there's a lot of different seams. Every manufacturer has their own. There's bulb seams, there's T seams. If you look at this clip right here, this is your standard male-female snap and lock interlock seam. This is a 90-degree seam with the bend here. Clip is internally fastened. Here's a 180-degree seam. If you notice on this, this one has a hook to improve the wind uplift, where this one, that hook doesn't exist. Then there's the old school batten type systems. The panel leg goes over and bends straight up, and then you cover it with a clip and a batten. You can have a narrow batten that doesn't have a gap in between the panels, or a wide batten where this is actually exposed to the roof deck below. All of them have their pluses and minuses, their positives and negatives and so on, and are used in different applications and are appropriate for different slopes. So they're designed with tall seams to resist leaks. Standing seam systems offer performance with aesthetics, they're my favorite, and with increased usage of metal panels on steep slope roofs rather than just for low slope metal buildings, many architects prefer to avoid seeing the exposed screws and fasteners attaching the panel to the structure. These are internally cleated, and that isn't an issue. So standing seam panels with no visible or exposed fastening devices for connection to the substrate can provide for sufficient attachment and thermal movement through the use of a properly designed and thermally responsive clip and fastener. So what I mean by that is certain standing seam assemblies are available with a clip that allows for unlimited thermal movement, and the panel can expand and contract and thermally cycle along that clip. The clips themselves are attached to the substrate and entrap the vertical panel legs. The concealed fastener connections eliminate the elongation of fastener penetrations from thermal movement, which is common to exposed fastener systems, and they greatly, if I haven't said it, greatly extend the weather tightness of that panel. So here's a couple difference of clips. There's one piece, there's two piece. Go down that rabbit hole later. But to accommodate longitudinal thermal movement on standing seam metal roofs, two types are typically used. Thermally responsive clip. A one piece and a two piece panel clips are designed to provide maximum wind uplift while still allowing the roof to expand and contract thermally. The one on the left shows the one piece with snap together metal roof panels that can thermally move over the top of the clip for unlimited thermal movement, and the right shows a two-piece application that allows the panel to float back and forth along the adjustment or ability of that two-piece clip, plus or minus 1 inch of thermal movement. So bearing plates, these are cool. So you're going to specify a roofing assembly, and say, for example, you don't want to use metal deck with insulation with a 1/2 inch jib for a fire rating, and then a underlayment followed by your metal clips and panels. You can use a bearing plate. Think of this as a snowshoe. So as you can see on the left-hand side, there's pre-slotted and pre-drilled holes in this clip, and it allows the panel clip to slide into this bearing plate slash snowshoe assembly, and it sits on top of whatever substrate you have. May not have the compressive strength, and when you tighten down these fasteners, it distributes the load like a snowshoe would on snow over a larger surface area, thereby not compressing the ISO beneath it. So you can use this without a JIP or a straight on deck assembly. So continuous seam is the name of the game when it comes to standing seam. Continuous seam panels can be used for long runs, low slope, and curved, radius, all kinds of different applications, but it's important to be aware of the limitations with each assembly. So, for example, continuous standing seam panels at extra long lengths perform no differently from a properly installed lapped panels. However, the extra long panels may be prone to installation damage and present a greatly heightened installation challenge. You may need a spreader bar, huge cranes, 1 man per 10 foot of a panel, so it can get very, very cumbersome and expensive. As an example, 3 50-foot panels are exponentially more simple to handle than one 150-foot panel, and may provide for a more suitable approach depending on your system and conditions. So, if continuous panels are required, ensure that you deal with a quality supplier. Some manufacturers offer mobile factory quality controlled roll formers operated by factory technicians that would otherwise roll panels within their facility. UL follow-up service certificate on machines, keep in mind it's 6 months. But please note, not all mobile roll formers have a UL certification. They're, believe it or not, they're not that expensive to buy, and there's quite a few people out there that actually have them sitting in their in their sites that aren't certified and aren't maintained and so on. So ask your metal roofing manufacturer for your mobile roll form or UL certification is highly recommended. Substrates and assemblies. So available in the market are non-structural metal roofing panels designed to shed water in sloped applications over solid substrates, as well as structural metal roofing panels designed to resist standing water over both solid substrates and open framing conditions. So an example of this is your traditional batten that I showed you that has the 2 panel legs that go up with a batten that goes over the top. The only thing that protects water infiltration within those panel legs in that seam, well, lack of a seam, is a batten. It must be used on 3 and 12 slope or greater. And it's not structural, so it must be installed over a substrate. The male-female interlocking and the mechanically seamed panels tend to be much more robust, and they can be used over open purlin or without a substrate. So you have limitations that are based on wind uplift, condensation control, but metal roofing can be installed over wood substrates, wood decking, plywood, nail-based insulation, SIPS panels, and so on. It can also be installed over steel substrates, including structural steel decking, light gauge, and secondary framing components, both in new construction and retrofits. And in some cases, with the use of bearing plates, can be installed directly over selected types of rigid insulation and cover boards without bearing plates that act as a non-combustible Class A fire-rated assembly. So I love collecting pictures of failed roofs, whether they're metal or built up, or flood and gravel, single ply. I just love them. So I've got a bunch of these, and if you want examples for any one of those types of roofing systems, reach out. Selecting the proper substrate is absolutely critical to the roofing installation, because a poor substrate can result in some pretty severe oil canning and potentially lead to premature failure. I've got some great failure photos right here of just some horrible substrate that should have never been used. So underlayment material options for your roof depend on what you're going for, but I'm going to put a caveat in there. My preference, which I don't believe is contained in this presentation, so take notes. Ready? My preference is a self-adhered membrane. You can use felt paper, synthetic membranes, modified products, rolled goods, but your choice really results in condensation control, snow density, rainfall density, and heat developed, and so on. So vapor retarders and underlayments vary from building to building with condition to condition, but they're generally installed on the warm side of the insulation or directly underneath the metal panel. The 30, 40 mil peel and stick membranes, sometimes there's 50, 55, 60s as well. They not only act as waterproof underlayments, such as valleys and roof edges and so on in critical areas, but they can be used as vapor barriers as well to provide early construction drying capabilities and a secondary roof membrane, essentially, between the metal roof and the substrate. So an example of this, and again, I know this isn't in the presentation, but this is my preference, is going to be a self-adhered, self-healing. And what self-healing means, when you run a fastener through it, it's going to seal around that fastener. Self-adhered is a peel and stick. Non-sanded, because you don't want the top sanded, number one, for people that are walking on it, to makes it slippery. And number two, if you have a panel laying directly on top of that membrane, when it thermally cycles, it over time is like a piece of sandpaper. It'll get to the bottom of that panel. And I like them 30 to 40 mil, and with an exposure time of at least 90 days, because it can be used to dry in a roof. And then, of course, the key to this is high temp. And again, if you want some failure photos of what not high temperature underlayment looks like when it's installed under a metal roofing assembly, reach out to me, because I've got some great ones. So gauge. A change in material gauge affects everything, positive and negative load carrying capabilities of metal roofs. There's a whole rabbit hole that we can go down. So due to the nature of exposed fastened roof panels, I'd like a heavier gauge material to be used to accommodate the requirements for positive loading. But with exposed fastener panels, 26, 24, and 22 are industry standard, and then 20 and 18 gauge are available for non-standard for select profiles, typically for added durability or for greater positive load carrying capability. On the other hand, standing seam roofing panels are generally offered in more standard gauges of 22, 24, and sometimes 20, because they're much more strong and they are dependent on the strength of the clip and the panel engagement and the pull-out value of the screw. So they're tested generally in 22 and 24. Although test data is sometimes limited, exposed fastened panels and standing seam panels can be provided in aluminum, copper, stainless, G60, G90, zinc. There's a whole list of things we can go down. But keep in mind, testing changes from each material to each material. So metallic coatings. The most widely used metallic coating for corrosion protection of steel. When I'm talking steel, I'm talking bare steel. You get sent a coil of bare steel. How do you protect it? It's aluminum zinc, which is composed of a 55% aluminum, 45% zinc by weight. I'm sure you've heard of some of these names: Al Zinc, ALZN, Galvalume, Zincalume. They're all the same, so pick one. Do you want Kleenex? Do you want tissue? The aluminum component of the aluminum zinc provides corrosion protection to the steel sheet along with a corrosion warranty, while the zinc component provides that sacrificial characteristic, that sacrificial layer that protects the material edges and cuts. And this is a huge component when in the field as well. So metallic coatings, when used for low slope roofing, the sheet performs extremely well, generally lasting for over 30 years without corrosion failure. So hot dip steel sheets are bare, unpainted. And what I mean by that isn't quite bare. They're Galvalume / Zincalume / ALZN / Alzinc coated, whatever term you want to pick. But they're up with a 25-year warranty against rust and perforation and so on. The product is also used as a substrate for a pre-painted sheet when a more decorative finish is desired. So keep that in mind. Before the paint goes on, you run it through and it's Zincalume, Galvalume, Alzinc coated. That's the substrate. This use has recently shown significant rates of growth as well. So zinc coated steel, which you often see as like a G60 or a G90, which is not warrantable, does provide some protection, the self-healing characteristics of zinc, but it's not warrantable. Again, it's recommended to specify products both pre-painted and bare. And again, keep in mind, bare doesn't mean bare, it means Zincalume, Galvalume coated. They are specified with the Zincalume, Galvalume coating, the 55%, 45%. So paint, there's a ton of paint options out there. Paint options include SMP, siliconized modified polyester, polyester paint, KNR 500, also known as PBF. I believe, if I get this pronunciation right, polyvinylidene fluoride. But silicone modified polyesters, SMPs, typically have a 20-year comprehensive warranty, and they're generally used on lighter gauge industrial products and pre-engineered building systems. They tend to flex better than KNR. So the lighter gauges flex more, so it's a better application for that paint. Both SMP and polyester paint coatings complement the industry with pretty economical paint systems that have decreased chalk and fade values, but they still support part of the market that is looking for a more affordable paint system as compared to KNR. So industrial, you're going to see a lot more with the lighter gauge applications on more industrialized projects. The KNR 500 is the most widely used in the architectural market, and it's a paint system containing, I believe, a minimum of 70% fluoropolymer KNR resin, and the chalk and fade qualities far outperform polyester, powder urethane, silicones, acrylics, and so on. KNR 500 may be warranted for up to 30 years. This also has changed somewhat recently with certain coating companies warranting their paint systems for up to 40 years. comprehensive. And please note, this warranty is limited to normal atmospheric conditions. So if you're going to be installing along, Puget Sound up in Washington, or along an ocean in Santa Cruz or San Francisco, there's other paint systems available for marine finishes, which have high build primers and so on, or you can always go the aluminum route as well. But reach out to me with questions on that. When Kynar 500 is coupled with zinc aluminum galvalume substrates, the product exhibits exceptional color stability, exceptional chalk resistance, durability, abrasion resistance, chemical resistance. It just goes on and on. Again, for severe corrosive or saltwater environments, paint manufacturers do have alternatives for the industry standard Kynar-based coatings with high build primers, Kynar top coats, multi-layered coating systems, and so on, with similar warranties as well. You don't have to use aluminum just because you're over water. So I like this slide. This one's cool. It shows everything, how it's broken down. In addition to coatings that have been developed through the use of reflective pigment technology and so on that meet the standards of pool roofing, quote unquote, for both solar reflectance and thermal emittance, many premier roofing systems, I should say, are being utilized that not only provide a high degree of weather tightness and longevity, but they're helping to keep the building itself energy efficient. I'm going to dive into this, but this diagram shows you what a typical Kynar coated panel looks like. Paint warranties. So if there's one thing I would say to reach out to me after this is over, is if you need help on specifications and getting things the way that you want them organized and or locked down and or so on instituted within your specs. When specifying paint, check the warranty carefully and verify the warranty coverage. Like, it's critical to examine this and not compare just the length of the warranty. The length of the warranty does not tell the entire kit and caboodle here. Some paint systems may be warranted for 40 or 50 years, but the warranty duration is not comprehensive, generally not comprehensive, and covers only the adhesion of the paint to the steel. So color, fade, chalk, oxidation, all equally important factors, should be covered for the same duration as the paint adhesion. It's also important to review the warranty remedy. Put that in quotes as well, that the manufacturer is willing to provide. Does the remedy cover replacement, or is it just repair or refinishing? So your panel looks weathered everywhere else but the brand new spot that was just finished with a huge eyesore. Is the total value of the remedy subject to proration? What's it worth after 20 years, and so on? So also, I want to point this out. Again, this isn't in the presentation, but when you're specifying, also make sure to include that you want fasteners, pre-finished fasteners, and flat stock to be sourced from the same manufacturer as the metal panels that you're installing. And the reason for this is I have seen time and time again, is a contractor will purchase metal panels through a manufacturer, and then they'll source pre-finished fasteners and flat stock locally from a building supply warehouse, especially in rural areas or areas where it's difficult to ship to or shipping's more expensive. So your hunter green or your royal blue or your regal white that every manufacturer on the planet carries may not be the same, and it may not be the same paint finish. So again, sheet metal flashing and trim should also be duplicated. Pre-finished fasteners and flat stock shall be sourced from the same manufacturer as the metal roofing panels. That's a caveat I should probably put in this presentation. Sealants. Sealants protect against moisture intrusion into the roof at exposed panel and flashing edges or lapsing conditions, and so on. There's various sealants used in the application of metal roofing. Each type has a specific characteristic and application that must be taken into account when installing a metal roof. So non-curing butyl, typically tube applied. This sealant should only be used in areas on a metal roof that are subject to dynamic movement of the panel. So including panel side laps, panel end laps, flashing attachments, or any metal-to-metal connection. So not only does non-curing sealant protect against capillary action, it also allows the panels and flashings to react thermally, expand and contract, without compromising the integrity of the sealant. Non-curing butyl will never dry out or break down, provided it's not exposed to sunlight. I did take a drink there. Talking and talking and talking. Okay. Extruded butyl tape. It's typically available in rolls up to 50 feet long. Extruded butyl tapes are used where long continuous beads of sealants are required in highly sensitive areas such as valleys, ridge caps, and eaves, and so on. This sealant should be used in all non-exposed applications as it will break down when exposed to sunlight. What was that, Jeff? What'd you say? The sealant should be used in all non-exposed applications. It will break down when exposed to sunlight. Butyl tapes are, in essence, the same as non-carrying butyl sealants. The exception is butyl tapes come in a variety of thicknesses, widths, lengths, and so on for specific applications. Most metal roofing details will call for the type and application of butyl tape that you need there. So don't focus on that too much. Just really keep in mind, it will break down when exposed to sunlight. Single component urethanes, typically tube applied, is used for any area of the roof that requires sealant to be exposed to sunlight. What was that, Jeff? Whether exposed to sunlight. Awesome. Often these sealants are used for applications where the metal roofing flashing when they integrate with another non-metal surface like masonry, block, stucco wall, split face, and so on. So let's review the specification considerations, very high level. Again, if you want to dive into this with me, reach out after this to help facilitate successful metal roof installation. So material quality in source, testing, some more testing, and more testing. The quality manufacturer can provide actual test data. Believe it or not, there are a lot of companies out there that have non-tested panels. Wind Uplift, ASTM E1592, test to ultimate failure. Air and water infiltration, ASTM E1680, 1646. Again, test to failure, ASTM test to failure. Manufacturer qualifications, how the metal panel is manufactured, the level of manufacturer experience. We can go down this rabbit hole forever. This is my nerd stuff. I love it. So when specifying a metal roof situation, attachment to the roof substrate is key. Installer qualification, level of experience. Are you manufacturer approved? This is also a big one. So manufacturer approved doesn't just mean, hey, I can buy your material. It means, have you been trained to install the specific roofing systems you're specifying from that manufacturer? And what a lot of architects don't pay close attention to, but vendors do, is does this contractor have the financial capability to bond and purchase the material, or are they tied up elsewhere, overextended, or is their bond on hold? So stuff to keep in mind. Finished warranties, weather tight warranties, verification of submittals, material gauge, testing, UL certifications, ASTM testing, require stamped calcs, and so on. I always like to write in my specifications that manufacturer supplied site specific, again, manufacturer supplied site specific calculations are to be provided. And we're not just talking zones 1, 2, and 3. You do the whole thing, walls, drainage, the whole bit. So now let's explore the energy efficient features of metal roofs, including metal roofing, solar panels, the environmental impact on metal roofs versus alternative roofing materials. So to begin, metal roofing contains recycled content. It's sustainable. It lasts much longer than most roofing materials. I've honest to God, been on a metal standing seam roof that was installed well over 100 years ago with a ball peen hammer hammered over male to female leg. It's fantastic. And I've got photos, reach out afterwards. In terms of a green building, it's important to choose and compare not only the life cycle of sustainability of a product, but also its full range of environmental and social impacts in order to choose the best solution. So to that end, there are software programs available for designer/architect use, ISO 14K, environmental standards, Athena, Eco Calculator, and so on. We can go down that afterwards on a one-on-one basis. So the environmental impact of roofing materials. Wow, this slide does not have the impact that it would if I was in person, does it? I would like to see your smiling faces, even if you're on a couch with a cup of coffee. We're going to skip past this right now and I'll continue on. Metal roofing is recyclable. It's very, very green. I'll dive into that. So cool metal roofing. Let's move on. How about that? Some coatings and finishes are available today qualify metal as a recognized cool roof product. So a cool metal roof has infrared reflective pigments incorporated into the paint for higher reflectivity values, even in darker colors. Again, even in darker colors. For instance, a roof with normal pigments may have a 0.07 reflective value, but improved to a 0.32 with reflective pigments. This image is a dark colored roof where heat is reflected into the atmosphere rather than into a building. Keep in mind, it doesn't get around your energy constraints in most cases. Like for example, in California, we have Title 24, and the only thing that meets the SRI reflectivity is a white roof above a certain slope. Again, reach out to me with concerns and questions after this is done. Cool metal roofing has a high solar reflectance value and a high emissivity value exceeding 80%. A cool metal roof will reflect solar heat back up into the atmosphere, lowering both the inside temperature of the building and the surrounding environment, and it reduces the heat island effect. Additionally, the life expectancy of that roof is increased due to the less expansion and contraction that it experiences. Also, if you have HVAC located on the roof, you can drop HVAC intake temperatures quite substantially, which also comes into play with white reflective coatings on low slope roofing applications. So, when specifying a metal roof solution, look for paints within high SRI, solar reflective value, that qualify for LEED and Energy Star and so on. Each color is different. Modular solar panels. Everyone wants solar. PV, the bane of my existence. It's very difficult to design a roof that is PV ready. Reach out to me after this is over again, but designing a PV roof, you need to take into consideration a lot of different factors that you may not know when this roof is specified, and I can help you through that. A metal roof solution can incorporate PV to improve energy efficiency of a building. Modular style solar panels offer higher power and efficiency, and they can be installed using a variety of mounting systems. I know I'm not supposed to say a specific product name during these AIA presentations, but I have my go-to. Reach out to me on this. It's recommended, well, I should say, I like to use clamps that clamp to the panel and don't penetrate the panel with typically a set screw. The disadvantages of this is that they are breakable and they don't permit foot traffic. So there's a couple different solutions that we can go through, but by far, if you want your warranty in place, my preference is with a clipped ballasted system, and I can work with you through this and give trade names and so on once this is over. So there's multiple factors that come into play. You can put panels down the center of a panel that you can walk on and so on, but most use roof clamps that are suitable for PVFs. Integral to the clamp on the previous slide, and others attached to grids, or you can penetrate the roof. Again, reach out to me once this is done. Keep in mind, exposed copper should be minimized or altogether eliminated due to concerns with dissimilar metals and electrolysis. It will impact, not can, it will impact the material warranty on this panel. Clamp-on systems typically don't void a warranty, but it should be noted, I have seen seam damage from clamp-on systems that aren't covered by most manufacturers. It's a third-party product, and most roofing manufacturers say, hey, this is my roof. Anything you put on after it, or third party, is not covered. So check your warranty terms and follow the clamp instructions, and especially the torque instructions on that, because one overzealous installer can ruin a roof. Some examples of some modular solar panels. And if you're interested in photos, again, I have a ton that we can go through on a one-on-one basis. So design and installation considerations related to metal roof assemblies include wind uplift, air and water infiltration, expansion and contraction, thermal cycling, drag load, and specifically installation details, which are very product specific. I did not know I was going to do that without me hitting play. I'm sorry. Wind is one of the most essential factors in roof design. I thought it was going to be cool, but didn't work out like I thought. The non-continuous attachment of metal roofs make them susceptible to wind uplift. Defining the upward force exerted by wind traveling across a roof. So poor design, faulty construction, or the selection of non-compatible materials often results in severe wind damage to the roof. And if the roof is damaged, your entire building envelope is compromised, the cost of which is often vastly exceeded by the losses associated with the interior damage and the interruption of occupancy and loss of business and so on. So wind uplift, key factors. Listed on this slide are several key factors relevant to determining a roof's ability to withstand wind pressures. Exposure to the surface irregularities of the environment of the building impact, the wind loading, and so on. ASCE 7 defines 3 exposure categories, B, C, D, and so on. Smoother terrain, the greater the wind load. I'm sure you're very accustomed to this. Basic wind speed, greater speed equals greater wind uplift. There's even special circumstances such as Miami-Dade. AAC 7 calcs the base wind speed with a 50-year mean recurrence interval measured at 33 foot above grade and exposure C. You can do adjustments to the calcs and so on for buildings located in exposure B or D. We can get involved in this in a one-on-one project-specific application. Building height. Wind speed increases with building height. If you have a one-story residence, you will not experience the winds at the top of the Burj Khalifa, the tallest building in the world. It's vastly different. So consequently, the taller the building, the greater the wind speeds and the wind loads. Again, I know this is roofing 101 for all of you. Roof slope. The slope also influences wind uplift. The lower the slope, the greater the uplift. Internal pressure as well. Wind striking a building can cause or increase the pressure within the building. Positive pressure is what I'm referring to, or it can cause a decrease in the pressure, negative pressure. ASC 7 supplies both positive and negative internal pressure coefficients for use in load calcs. And again, site-specific calculations from the manufacturer of your roofing panel is key. So structural standing seam panels are tested under ASTM E1592, a standard test method for structural performance of sheet metal roof and siding systems, which uses a uniform static air pressure difference. All standing seam roofing metal panels should be tested under UL 580 uplift test to meet the requirements of the industry. Additionally, the manufacturer should subscribe to the UL follow-up service. Because projects often require more stringent test results, many standing seam panels, manufacturers test their metal roof panels with other testing agencies other than UM, such as ASTM, Factory Mutual, there's the Miami-Dade cert. Unlike UL, which is a pass-fail test, ASTM, which I think is a fantastic testing, and FM takes the panel to failure and provides that data to develop accurate negative pressure information useful for determining panel performance and clip spacing. This is awesome testing stuff. I know it's somewhat nerdy, but I love that stuff. ASTM pushes to failure. As a result, metal roofing systems can be designed by a professional to meet local code specific wind uplift requirements on almost a table-based system. This is the single most important factor in determining to ensure a roof will stay on the building. And I have quite a few photos of roofs that are blown off if you're interested. So air and water infiltration. In addition to the wind uplift testing, metal roof panels should also provide air and water resistance rates that are acceptable to the industry. Standing seam panels can provide adequate air and water infiltration control and are often tested through ASTM E1680 for air and ASTM 1646 for water. With proper sealant in place, exposed fastener panels can also provide adequate air and water infiltration. talk to me about that offline on a project-specific application. And in addition, structural standing seam roofing panels that require mechanical seaming in the field and also require panel-to-panel end laps due to extremely long lengths will often be tested under ASTM E2140. So this is a water infiltration test of the panel-to-panel end lap with 6 inches of standing water over the panel lap for a condition of 6 hours with no signs of leakage. So as I was saying previously, your continuous panel lengths versus lapping panels is a very project-specific application. In some senses, it may make sense to run a seamless 100 or 150 foot panel. In other cases, it may not. Expansion and contraction. All metals used in roofing, or period for that matter, expand and contract with changes in temperature, thermal cycle. This must be taken into account when designing metal roofs. Most metal roofs form their own design, and in large part, the necessity of providing for expansion and contraction, buckling of sheets, tearing at seams, loosening or pulling through of fasteners, they're all common failures caused by inadequate provisions for expansion and contraction. The rate of expansion and contraction differs with each metal, as shown in the table. So, for example, steel as compared to aluminum, night and day difference. Night and day difference. Again, talk to me offline about proper applications for this. So the thermal movement part, now we get interesting. There are 3 ways to accommodate for thermal movement: at the low end of the panel, at the high end of the panel, or both. And I will go through applications for each of these. Typically, panels are pinned at the high end or at the high slope of the panel, the ridge, to accommodate movement at the low end of the panel, so it expands down slope. The high end is pinned or fastened to the structure to keep the panel from sliding down the slope and to direct thermal movement down slope. So you have your drag load and your thermal movement and everything. With the whole kit and caboodle pinned at the ridge, the low end of the panel is then hemmed to hook around a cleat to allow it to expand and contract at the eave/low side of the panel. To accommodate movement at the high end of the panel, and you're probably questioning, Jeff, why would you want to do that? I'll get into it. The low end is pinned to the structure. The high end floats. This is a floating ridge condition. To accommodate thermal movement, this method requires exposed fasteners at the low end of the panel. It may be an aesthetic concern. The third method is to allow expansion and contraction at both the high and low ends of the panel. This requires pinning somewhere in the middle of the panel, usually at a lap. Generally, this is done on extremely long panel runs on a lapped system if you do not go full panel length, where the expansion and contraction is so great that it makes it difficult to allow for it at just one end, or if the thermal movement exceeds the capacity of the clip. In these instances, the overlap between the hidden cleat and the turn under end of the panel at the eave may need to be increased to accommodate for thermal movement. It's important, though, that the panels are not pinned at more than one location, such as improper fixing, say at the attachment points for flashings and so on, as it would not allow the panel to expand and contract in the manner that you're after. This is a diagram of a typical panel installation. Maximum panel lengths are generalized for this slide, but they show different points of fixity. So if panels are fixed at the high end or the ridge condition, free movement is required at the panel's low end or eave line. This is your typical installation. Pictured here are examples of a proper and improper eave detail. The correct eave detail is absolutely critical for long-term success of the roofing installation. these are generally manufacturer provided details. This one's pretty. So a knee joint. This is becoming a very common condition. I have to say, I've seen a design trend, just going off my slides for a second. I've seen a design trend that a lot of architects and design professionals are designing what's called a roof to wall transition, where it's a seamless transition from standing seam on a roof, turning and running down a wall. It looks absolutely fantastic, but there are substantial design considerations to take into mind when doing this. I've done hundreds of these at this point, and if you're nodding your head right now saying, yep, Jeff, I thought about that too, you're not alone. I've done this. Reach out to me. I can walk you through how to do this properly. A knee joint or kneecap is used to cover a cut in the vertical panel rib when a standing seam profile transitions from one fascia onto another continuous piece. This can be used for mansard with very short lines and so on, or from a roof to wall transition, which the design community again seems to be moving towards. It does allow for clean aesthetic lines to transition from the roof down a wall. So here's a short run where thermal expansion and contraction doesn't come into play as much because the turn down the wall is only about a foot, and it's pretty straightforward. A knee joint or kneecap is used to cover the cut in the vertical panel rib of the standing seam roofing panel that transitions on this fascia to be one continuous piece. Up close, it looks like this. Far away, it looks seamless. This allows for very clean aesthetic lines to transition from the roof to the wall. If you're going to run it down the entire side of the wall, reach out to me. So care must be taken when utilizing these kneecaps for fascia transitions because it establishes a point of fixity. The length of the sloped panel is also huge. What is your upslope? If the edge there is fixed, what is your distance from the quote unquote eave up to the ridge? That comes into play with how much thermal movement is going to occur because the panel must now be allowed to expand up slope. Additionally, what is your slope? I hope it's not 10, 12. That's more difficult. It's expanding against gravity. Stresses to this knee joint developed by expansion and contraction can quickly deteriorate the integrity of this detail, and no one has found a better detail. As time passes, hopefully maybe someone will figure out how to do this seamlessly, but as for right now, and probably into the unforeseeable future, this is how it's done. It should not be utilized, though, in climates where massive snow may occur. Snow movement, ice dam effect, and so on, expansion and contraction of water within that will burst it wide open. So for example, when an architect was speaking to me about using this in Alaska, we made a consideration and we did a design change. Instead of doing a one-piece transition, we did a two-piece transition, and we made the eave very small, and we attached the wall panels directly in line with the roof. So it looked seamless from far away, but it was actually a two-piece transition detail. Standing seam on the wall in perfect alignment with on the roof with a very, very short eave detail. So snow does come into play. The floating ridge detail is key because it must be allowed to expand upslope since you did establish a point of fixity at that eave. Drag fasteners don't penetrate the substrate. The panel end support is required for a secure connection of the Z-cluster to the panel. And the ridge cap, which is a step, acts as a hinge point, which allows the cap to flex when the panel expands and contracts. You can see that in the detail. So what's this one? This one is fixed lap. Fixed lap detail locks the panel at the lap location. This also requires the high side and low side to float. So generally speaking, this is done on your long panel runs where a continuous panel is not utilized and where expansion and contraction is so great it may be difficult to allow for it at just one end, or again, if thermal movement exceeds that of the clip. In these instances, the overlap between the hidden cleat and the trim under end of the panel at the eave may need to be increased to accommodate for thermal movement. It is important that the panels are not pinned at more than one location. You have to allow these things to move, such as an improper fixing for flashings, again, as it doesn't allow the panel to expand and contract in a controlled manner the way you want it to. So, stagger lapse. Looks better. Again, this is all if you're not using a continuous length panel with unlimited thermal movement, which we can also do. Fixed clips operate on the same principle as a fixed lap. They will require both the high and low ends of the panel to float. Fixed clips, are most commonly found on continuous long length panel applications or fixing the apex of a radius application. How do you drop the install cost of a barrel roof? Lapped panels. So fixed clips operate on the same principle as a fixed lap. They both require the high and low ends of the panel to float. Again, they're most likely found on long length panel applications or for fixing the apex of a radius application. So it allows your panel to expand down the radius on either side. Radius applications require the apex to be fixed and or pinned. The panels cannot fully expand and contract around a radius due to the curve of the panel. This must be taken into consideration. If a panel floats around the radius without a point of fixity at the apex, oil canning or a deflected appearance can take place, will take place. It will not look good. So some things to take into consideration for a barrel roof. Radius applications do require them to be pinned, the apex to be pinned. Panels cannot fully expand and contract around a radius due to the curve. Again, it will oil can and so on if not done properly. So, varying panel
I'm going to interrupt for a moment here. We've just got a couple of minutes left, and I know you have a few slides left to go. So we're going to run over time, and that's fine, but please stick with us, okay?
I can blow through the elasticities pretty quick. I don't have the time, so I apologize for that.
That's right.
Varying panel width and thermal movement must also be considered when detailing full-length roof panels at the gable ends of a building. In most cases, installers will not be able to utilize a full panel width at the ends of the building. So this detail allows for cutting the panel the necessary width and field bending the panel edge up 1.5 inches or so on. The 1.5 inch turn up is to protect against infiltration of wind-driven particulate and so on. Once it's been turned up, the panel edge is inserted into the receiver trim and secured against wind uplift. This detail also allows free thermal movement of the panel within the receiver trim. Drag load. We'll go through this quick. Panels are pinned to allow the panel to move more freely under the thermal load and resist a drag load caused by the weight of the panel, live snow loads, and so on. Slope of the roof, length of the panel, and the loads involved all come into play. Cold climate design. Metal roofs are often the choice in cold climates. You may need to address ice dam considerations and formation due to building heat loss, solar radiation, vapor dry, snow retention, ice melt roofing systems, same as for flashings and so on. Cold roof systems that keep the roof temperature near the same as the temperature of the outside air may be best when concerning trying to deal with ice dams. But generally speaking, in heavy snowfall areas, you want it as steep design as possible to allow for snow runoff. And a self-adhered underlayment should always be utilized. Again, high temperature, even though you're in snow. We'll move on. Snow retention devices. Reach out to me. There's a lot of industry trade names I can't mention. Similar to PV, they should be the screw clamp-on set type with no penetrations. Don't penetrate the metal panel. Wide valleys and so on require special considerations for snow and ice runoff. Your tributary sources add to that, and it exponentially makes your runoff larger. So pipe boots. Pipe boots are often used in roof penetrations, and for various reasons. One of the most common is ventilation of exhaust and so on. But they should be located in the middle of the roof, pan, if possible, centered with 3 inches on either side to allow for adequate runoff. But Jeff, I have a big pipe. How do I handle this? Put it on a panel rib. Use a panel rib cut detail. So here is a proper cut rib detail. Cut the rib home plate should be used on penetrations to come through or near a vertical panel, but you can't put in the middle. Cut the ribs with a shear, never a blade or a torch. So improper versus proper. Pipe boots are typically not manufactured by metal manufacturers and they come from third parties. Pay attention, please pay attention to this, installers. It must be attached to the panel and not the roof substrate. If you attach it to the substrate, it doesn't move with the panel. That's the whole point of a pipe boot. Roof curves. Use a curb whenever you go big. Keep going on. Where are we here? Are we almost done? I made it through. Look at that. I made it through in time. Hey.
Thank you, Jeff. That was a great presentation. I'm sorry to have rushed you along there. I didn't realize how much, there were about 10 slides left and I didn't realize how many would be going.
I blew through that pretty quickly to hopefully save some time.
Why don't you put it on the last slide so folks can see your email address? There's a lot of people who had questions, and you mentioned many times that to ask people to follow up with you. And I know a number of people, but from the questions they had sent us, have very specific questions about applications they're looking for help with. So you're probably going to get inundated pretty quickly. I do have a couple of questions here, if you don't mind hanging with us. Going way back to the very beginning, I think this Chuck is asking about, I think it was the exposed fastener fastening system. He says, will the fasteners pierce through a ½ inch sheathing? And if so, what sheathing thickness must I use to avoid this?
Okay. So I need to know the rest of your assembly. Generally speaking, when you're installing a roof, fasteners need to penetrate the substrate by 3/8 of an inch. I understand there are special considerations where you have like a TNG and you want to look up and see a beautiful wood deck below and you do not want them to penetrate. If that's the case, I say pre-drill, and pre-drill, and then fasten through, and you want to leave about 1/4 to 3/8 of an inch exposed so it won't dimple. Dimpling is what I'm concerned about if you do not want penetration of a fastener. Sizes, again, will depend entirely on your substrate and construction, deck thickness, insulation thickness, and clip used, and so on. But to answer your question, pre-drill, measure the depth, pre-drill, and use an appropriate fastener that will not go within 1/4 to 3/8 of an inch of the bottom of your deck that you do not want penetrated.
Great, thanks, Jeff. I have another question from Leslie, and this is going to go leaning into your law experience, asking about color warranties, if they're transferable if the building is sold. That's a little bit.
Man, that is a catch-22 question because I can't answer for every manufacturer. And I can't really give trade names. So my answer to this would be a very political one at the time. Look to your metal manufacturing warranty terms. It should be contained within the warranty language. I know that some single-ply warranties don't transfer, but from my experience, typically metal finish and color warranties transfer as generally speaking, as long as the manufacturer is notified and a transfer, and sometimes a transfer fee is paid.
Thanks. I've got a couple more questions here, and I'm not going to get through all of them. There are quite a number of them, but Randolph is asking about wind uplift and whether that's an issue when panels are installed over a continuous plywood substrate.
100%. 100%. Always, always, always do wind uplift calcs. Wind uplift changes on a site-specific nature. Your building type, your building occupancy type, your surrounding conditions. Are you at a city center, or are you up on a ridge next to a lighthouse, or are you in Miami-Dade? Like, for example, Flood and gravel roofs, I believe, still aren't permitted in Miami-Dade because when a hurricane comes, it picks up the rocks and throws them at 200 miles an hour through windows. So every single metal roof is site-specific conditions, even over solid substrate, because the substrate change also impacts that. So if you have, you know, 1/2 inch OSB versus 3/4 inch 5-ply, it's different. So always site-specific calcs, and reach out to me with any questions on your site-specific buildings.
Great, thank you. And Milton's got a question going back to your discussion about dissimilar metals and electrolysis. And you mentioned lightning protection cables. What materials should you use with lightning protection cables to avoid the dissimilar metals issue?
Take that with me offline. That one can get.
Okay.
Yeah.
Milton, you hear that? Take the follow up with Jeff offline. I'm going to ask one more question. Thanks very much. And this one from Ken, he's asking about when you have a cut edge with a Kynar finish on Galvalume panels, he's running into problems with edges bubbling and corroding where they've been cut. And is there a solution to that?
Yes, there is. So typically speaking, when you cut a metal panel, whether it's finished with a Kynar finish or a Galvalume finish, quote unquote bare versus painted, you want to use a shearing motion. If they are cut with a grinder and it doesn't shear that metal quickly, that sacrificial layer won't, for lack of a better term, fold back over and protect that panel. So if they're corroding, it sounds to me like it's improper installation and they're being cut with a grinder or other cutting method instead of with a shear force.
Okay. Great. Well, I think that's all we have time for, Jeff. Great presentation. Lots of questions to follow up, and I think you're going to get inundated, probably more than you expected. Again, to the audience,
leave it alone for a while, so we're okay.
If you want more information, you can go to aepspan.com as well as to Jeff's email. And a reminder that the AIA credits and certificates will be handled automatically. Give us about 7 days to process those. And tomorrow, about 24 hours after the end of this webinar, you're going to get an email, and that is going to have links to the handouts, to a recording of this webinar, and to links for more information if you need it. Thanks, everyone, for attending. We're going to do another of these. Let's see, I think it's June 18th. And June 18th, Strategies for Success with Aluminum Zinc-Coated Roofs, presented by Steelscape. You can always find the latest webinars that we've got going up at Metal Architecture at metalarchitecture.com/2020-events. Jeff, really wonderful presentation. Thanks so much. I appreciate it. And thanks to all of you for attending. Have a great day.
Thank you very much, everybody.